Okay, so let's start off with redox. Okay, so this is going to be a new chapter, so I'll be going through everything from scratch. So let's start. Okay, so what exactly is a redox reaction? So redox actually stands for reduction and oxidation. So that's why it is called redox. So you can see here is red ox. So redox reaction actually consists of two processes happening at the same time. The first thing is the reduction process. The second thing is the oxidation process. So redox reaction, you can look at it in a few ways. So some of the key concepts of understanding how redox is actually working through. First thing is this. Okay, oxidation, you can look in terms of the oxygen gain. Reduction, you can look in terms of the oxygen loss. Okay, so oxidation, you can look at in terms of whether oxygen is gained or not. Reduction, look at it in terms of whether oxygen is lost or not. So the first idea of understanding, first idea of really looking into redox is looking at the change in the oxygen, whether it's a gain or loss. Okay, another way of identifying whether there's a redox reaction is really looking at the hydrogen itself. Okay, so oxidation is the loss of hydrogen. Reduction is the gain of hydrogen. Okay, so that's for the second point. The third point, oxidation, okay, is the loss of electrons. Okay, so electrons over here. The third one is the gain of electrons. Now, I think before we go into the fourth point, I just want us to look at the first 3 points here. Okay, what exactly does it mean by the gain of oxygen, the loss of oxygen? So, I think one very simple way of looking at reduction, we could look at a blast furnace reaction where we have our iron trioxide, Fe2O3, okay, becoming Fe. So what you realize in this process over here, okay, let's just look at the right. Okay, in here, there's actually a loss of oxygen. How do you know? Fe2O3, you can see there's oxygen attached over here. Okay, but now there's no more oxygen. So that's why in a blast furnace reaction, it's actually a reduction reaction because there's a loss of oxygen. Okay, now what's an example of a gain of hydrogen reduction reaction? Okay, I'll be looking at the reduction side later on. Oxidation, you'll see some of the examples now. So I'll just focus on the reduction side first to show you some of the examples. Okay, another example would actually be in terms of the reduction using the hydrogen concept. Is that I have water. Let me change my pen color. Okay, I have oxygen, O2. Okay, when you gain hydrogen, the most common one is, you know, that it will become water. So you can see oxygen here, okay, is actually reduced, okay, because it gained hydrogen. So this is about the gain of hydrogen concept. Okay, the last one is really looking at in terms of electrons, the third concept here. So how do I exactly know whether there's a gain of electrons or not? Is by looking at the charge itself. So what do I mean by gain of electrons? So for example, I got Cu2+, it became Cu. So for Cu2+ to become Cu, you know that in the process, in the midst of the whole process, it must have gained 2 electrons. Okay, so you can see here, Cu2+ to Cu is a reduction process because there's a gain in electrons. Okay, oxidation wise, I didn't give an example because I just want to focus on only one side for now because these are just examples. Later on, you will see more of them. Okay, the last one, okay, is in terms of the oxidation number. Okay, oxidation number. So that's the fourth concept we're going to be looking at, and that will be actually the most important one. So oxidation is an increase in oxidation number. Let me change the color, sorry about this. Okay, it's the increase in the oxidation number. Whereas in terms of reduction, it's a decrease in the oxidation number. So these are the 4 ways we can actually define redox. Okay, so let's look at the first 3 methods. First, gain oxygen, loss hydrogen, loss electrons for oxidation, loss of oxygen, gain of hydrogen, gain of electrons in terms of reduction. Okay, so in conclusion of all of the first whole segment, right, before we go into all the examples, really is in terms of, in a redox reaction, one species is reduced, okay, the other is oxidized. Okay, that's why the whole thing is a redox reaction, or redox pair, redox reaction, or a redox reaction, redox pair lah. Okay, so this is what we're going to do now. We're really going to look at some of the examples, and then from there really gain a deeper understanding of how we can identify redox reaction and how exactly do we go about explaining it. So let's start. Okay, the way to go about doing this is really to zoom in on it. Okay, definitely yes. Okay, but we're going to compare substance to substance. So for example, initially I got magnesium. After that it became MgO. So let's draw a nice arrow to go over here. So you know that in the process Mg2 becoming MgO, it actually gained oxygen. So if it is a gain oxygen process, one thing we know for sure is this will be an oxidation reaction. Okay, I'm going to use a different color now to show for the other element. So CuO to Cu, CuO to Cu. So you know that there is a change over here. In this case here, CuO to Cu is a loss. Okay, they lose oxygen. So you lose oxygen, this is known as your reduction. Okay, so let's go and write out the answer now. So for the answer, let's use respect to rate. The substance that's oxidized, okay. So we are looking at the substance as being oxidized, so we look at the reactant here. So substance oxidized is actually Mg. So how exactly to write the reason? The reason, the way to write it is as such. So we're going to write Mg. Okay, so substance oxidized Mg. So magnesium, okay. Reason is because magnesium gain oxygen to form MgO. Okay, that's how you go about writing the reason. I'll explain a little bit more further later on. What's the substance that's being reduced? The substance that's being reduced is actually CuO, copper oxide. So what's the reason? Because CuO lost oxygen, okay, to form Cu. So if you look at it in terms of the explanation wise, okay, really you can see there's an idea of before and after, and it's not just about before and after. How do you identify? Is really because what's the process here? Gain oxygen. So same way for the reduction, you realize that the process here is about losing oxygen here, okay, and this is the before, this is the after. So there's always the before, what's the process, and then the after. Okay, that's how you go about writing the reasoning behind the explanation itself. Okay, so let's go on to the next page to see more examples. Okay, substance that's oxidized, substance that's reduced. So we have Fe2O3 becoming Fe. So this is our blast furnace reaction. Okay, so Fe2O3 to Fe, we know that from here to here, this is actually lose O. So this is actually oxidation. Use a different color now for the other one. So CO, lose O, lose O, this is actually reduction. Okay, my bad. Let me change the color. Oh no, sorry about this. Lose O is reduction. Okay, then the second one that we have over here, CO to CO2. This one over here is actually gain O. So this is actually a oxidation. So substance that's oxidized, answer will be CO. Okay, let me use back to my rate. So I know CO is oxidized. Reason is because CO, what happened? It gained oxygen to form CO2. Okay, you realize that I did not include the balancing equation number. Okay, the stoichiometry number I didn't include inside over here. Okay, because that's mainly used in your mole calculation, that's mainly used in your balancing equation. Okay, however, when you're writing this, okay, you realize that we will exclude the balancing numbers. Okay, so substance oxidized is the substance itself without the balancing number, the stoichiometry number. Okay, so just take note of that. Substance that's reduced is actually Fe2O3. Why is it Fe2O3? Because we know it loses oxygen, right? So reason, Fe2O3 lost oxygen, okay, to form Fe. So this is how you go about doing the explanation itself. Once again, you can see that there's a before, process, after. Before, process, after. Okay, so that's how you go about writing the explanation. I'll just be going through question 3 and 4 itself very quickly. Okay, so I'm not going to change color, okay, so I'm just going to use the same color throughout. So NH3 to N2. Okay, so NH3 to N2, this is really because I lose hydrogen. Okay, so lose hydrogen is oxidation. This one to this one over here, I gain hydrogen, so this is a reduction. So substance that's oxidized is actually NH3. Okay, how do you know it's NH3? Reason is because NH3 lost hydrogen to form N2. Okay, so if you can't remember, you can always go back to the previous slide. Then you can scroll down all the way and see, oh, lost hydrogen is oxidation. Okay, so be familiar with the four ways to identify whether it's oxidation or reduction. Okay, be familiar with them. Let's go back to here again. So NH3 lost hydrogen to form N2. This one over here will be Cl2 is the one that's reduced. How do you know? Because Cl2 gain hydrogen to form HCl. Okay, so this is the next question over here, and the last one. Okay, you realize H2O is highlighted in yellow because we want you all to just ignore the H2O over here first. Okay, based on the gain hydrogen, lose hydrogen, gain oxygen, lose oxygen concept, actually it's a bit difficult to differentiate what's happening over here. So in this case, we're helping you here first by telling you just ignore this first. Okay, so let's compare HBr to Br2. Okay, so let me erase this one. So HBr to Br2, if you look at this over here, this is actually about losing H. This one here to this one here is actually about losing O. So you realize we are blending, okay, we are mixing two of the loose gain things together, hydrogen and oxygen concepts over here. So if I lose hydrogen, I lose oxygen. So question, is it oxidation? Is it reduction? Which one is it going to be? If you can't remember, you can always go back to your previous slide, okay? So, okay, I got loss of hydrogen. Lose hydrogen, oxidation. Lose oxygen, reduction. So remember this. Now let's go back, okay, to the slide. So I know lose hydrogen, this is oxidation. Lose oxygen here, this is reduction. So substance that's oxidized is actually HBr. Okay, so reason, because HBr lost hydrogen to form Br2. Substance that's reduced is SO3. Why is SO3 reduced? Reason is because SO3, lost, let me erase, okay, lost oxygen, okay, to form SO2. Okay, so that's the end for this page. Let's go on to the next page where we are looking at the loss and gain of electrons. Okay, so now let's go on to the third concept over here about lose and gain of electrons, Zn to Zn2 plus. So for Zn to become Zn2 plus, we know that it is lose 2 electrons. Okay, if we lose 2 electrons, actually it's oxidation. So lose electrons is oxidation. Cu2 plus to Cu. So this is actually gain electrons. To be more precise, it's gain 2 electrons. So this is actually reduction. Okay, what are you supposed to write here? This is actually Zn to Zn2 plus the half equation. In this case here, we're looking at half an equation only. But what you should be writing over here would be Zn to Zn2 plus 2 electrons. Okay, your teacher, isn't it lose 2 electrons? Shouldn't I write subtract? So in chemistry, we don't really write a subtract sign. Okay, so to show that it has lost 2 electrons, we actually put the 2 electrons over here. So what this means is Zn, when it became Zn2 plus, 2 of the electrons are released. Okay, as gone somewhere else. Same way, Cu2 plus, okay, you gain 2 electrons to become Cu. Okay, so this is how you go about writing the half equations. Okay, we'll go more further in depth in subsequent lessons. Okay, but right now what we have here, okay, is how do we go about explaining this. So let's go back to my red pen mode. So substance that's oxidized, we already identified is actually Zn. So you realize I didn't write the state symbols there also. When you're writing for a redox, the state symbol is really not required. Reason, okay, is really because Zn lost electrons, okay, to form Zn2 plus. You want to be more precise? Yes, you can write 2 electrons over here. Same way, substance is reduced. What's reduced is actually Cu2 plus. How do you know? It's because the reactant, Cu2 plus, okay, gain electrons. So let me scroll down a bit more so that it's clearer. Okay, gain electrons to form Cu. Okay, you want to be more precise again? Yes, you can say gain 2 electrons. So this is how you go about explaining it. Same way, let's go down to the next one. Fe to Fe2 plus. This one over here, you know that it is lose electron. This one over here, plus to no plus, so this is actually gain electron. So lose electron is oxidation. Gain electron is reduction. So substance that's oxidized is actually Fe. How do you know? Reason is because Fe lost electron to form Fe2 plus. Substance that's reduced. Okay, reduced, what is reduced? Reduced is actually your H plus. So H plus is, how do you know? It's because H plus gain electron. Okay, please spell it out in full, don't just write ER. Okay, to form H2. Okay, so you can see the before to the after. Last one, okay, last example over here. So what I have is Fe2 plus, Fe3 plus. So this is from 2 plus to 3 plus. This is actually loose electron, so must be very clear. This loose electron. Cl2 to Cl minus. This is actually gain electron. Okay, so spelling adjust. So if I lose electron, this is actually oxidation. Gain electron, this is actually reduction. So how oxidized? What is oxidized? Okay, by now you should be very familiar with the style of writing already. So reason is because Fe2 plus is oxidized. Why Fe2 plus lost electron to form Fe3 plus. What is reduced? Cl2. So why is Cl2 reduced? Because Cl2 gain electron to form Cl minus. Okay, so you realize I also didn't include all the stoichiometry numbers. So just take note of this. Okay, so there are 3 examples over here. So I was telling everyone, maybe you don't focus on what's oxidized, but instead, yeah, you do both again. So which substance is oxidized and reduced. Okay, so you might want to like have another line over here, have another line over here. I'm sorry for the ugly lines over here. Okay, let's draw a line. Oh, oops. Okay, so you can draw a line. Okay, to just really go and make sure that you are fully able to explain both the redox, okay, the reduction and the oxidation. Okay, so one more over here. Okay, so just make sure you can complete this as a practice to see whether you're able to do it or not. Okay, so that's all for this segment.